So in the last part of the wave-fun lab simulations, we're looking at what's called the superposition of waves. Very important idea. You just saw how with our guest speakers, right? If you flip the wires, you just ruin like a nice $800 surround sound system. And that's because instead of having constructive interference, it's the opposite. What's it called when you cancel out the waves? It's called destructive. If I have a 2-foot crest meet a negative 2-foot trough, theoretically, if you're right in the middle, let's say you're at the new Hinsdale Central wave pool. We're going to put on a new swimming pool so we can actually host like state because we win like all the time. And then while we're at it, let's make some money so we can buy an air conditioner, yeah? We're going to put a wave generator in there. Lots of fun. And then we'll sell non-alcoholic beverages, slushies, and you can go right up in your rubber ducky and get a pina colada. Let's say you want to play a prank on one of your friends. They're right here, and you're going to send a 2-foot crest and a negative 2-foot trough. What's going to happen to the person right here if they're right in the middle? Theoretically, if they're right in the middle, are they going to get buried by water right in the middle? No. Theoretically, you would actually feel nothing. Isn't that cool? Because at that exact point, the waves perfectly overlap, and they totally cancel out. The extra water from that 2-foot crest fills that 2-foot trough. You see that? That's cool, right? That's called destructive interference. So theoretically, if you could match it just perfectly, you would cancel out that wave. In fact, that's how those noise cancellation headphones work. Anyone have a set of those? Like you wear them on the airplane, if you're traveling, maybe your old man's got one. The best ones are made by Bose. They're like $300, $400 when they came out. Now they have cheaper alternatives, and I think Sony has a knockoff for like $99. There's a $50 version. I've seen it as cheap as like 25 bucks. And that's because noise cancellation headphones will protect your hearing. You don't have to turn the volume up as loud when you're watching a movie or because you can cancel out the outside hum of the engine. What's really hard is you have to generate exactly the anti-sound. Is that easy to do? I have to be able to predict exactly what sound's going to get to my ear and then generate the exact opposite. Easy to do or hard to do? Pretty hard. So the way noise canceling works is it's better for repetitive sounds like the hum of an engine, train noise, etc. So noise canceling headphones actually have a microphone to pick up outside noise, and then there's a chip that flips the sound wave and an extra set of speakers to try to cancel it out. Pretty cool, right? Someone was telling me like their old man, their dad's new Lexus or Cadillac actually has active noise cancellation in the car to try to cancel out outside noise. It's really cool. It's a basic idea. Now how about the opposite of destructive interference? What would the opposite be? It would be what? Constructive interference. This is called superposition. All it is whenever waves crash together, they interfere. That's called wave interference. When you play ball, you usually don't have illegal interference, right? But when the waves crash together, the net result is you just add them up. The principle of superposition states that when 2 or more waves interfere, the resultant wave is the sum of each wave's amplitude at each point. Complicated. So if you really wanted to punk one of your friends and they're in like a wave pool, what you would do is, let's say we want to get one of your buddies here. They're sitting on their rubber ducky, drinking their pina colada, non-alcoholic. There you go. You would send a 2-foot wave and another 2-foot wave. What's going to happen to your friend? Bam! They're going to get buried by what? Hoo-ah! How many feet of water? Everybody. Bam! 4 feet of water. You see that? Kind of cool there, right? So what's nice about this simulation is it helps you visualize what's going on. So in big fancy words, let's kind of summarize. So the fancy term is called interference, when waves overlap. So 2 interesting consequences occur, like we just talked about. One is called constructive interference, where the waves will build up because they're in the same phase. And then the other is called destructive interference, where they tend to cancel out. They're out of phase. And that's what happened on our guest speakers when I hooked them up backwards. They sounded really bad. I don't know if you ever noticed, but in our gym, is the sound really good or really bad? It's really bad. And those baffles on the ceiling there, that's to try to absorb the reflections. Because when you hit a hard surface, the wave gets flipped 180 degrees out of phase, out of sync, and you tend to get destructive interference. So we try to minimize that with baffles. Maybe you've been to a concert where the acoustics are bad, and you're in a seat where the sound is really bad, right? And that's because the waves are canceling out there. So if you actually just move over to the left or right, maybe 10, 15 feet, you might be where you're getting constructive interference. It sounds a lot better. Whereas our auditorium, it's designed to be like acoustically perfect. It sounds really good. Okay, we want to see if they're in phase or out of phase, if they match or not. And all you do is you apply the principle of superposition to figure out what happens. You add up each wave's size at each point. So if I zoom in here, you can see that I have 2 waves right here. Let's say this one's 3 feet, this one's 4 feet. So in this case, when they add up at the maximum point, am I going to get how big of a wave? 3-foot wave, a 4-foot wave, it'll be what? It would be 7 feet. You see that? And then do waves bounce off each other or pass through? How could you figure that out really easily?